Hey, welcome back, guys. This is TechBus episode 11. We're here with Nate Watson, the president of Contemporary Analysis, and also the founder of a new code school class called Data Science Academy. And so we'll be talking about both of those. So thanks for being on the show.
Thank you.
Just going to turn it over to you and just kind of introduce yourself and let us know what you're all about.
Contemporary Analysis, we started in 2008. We're a predictive analytics company. We help businesses two ways, really, interact with their data. Businesses have a lot of data. They don't know really what to do with it. We, a lot of times, are their first interaction with data science. We help them spin up a whole data science unit, whatever that means, along with the political hoops that we have to jump through, the red tape that has to be cut. And then at the end of a predetermined set of time, 18 months, 2 years, 3 years, we actually hire, train, and place a data scientist for that company, sell that to that company, and then step back and actually become staff augmentation for that company. If that already exists, then we just come in as staff augmentation. And so that allows us then to provide talent. We're the cavalry. We are the heavy bombers. We are the tech talent you hire when your data scientist is either too busy or it is above their head. And we've built a whole company on it. We're very, very proud of some of the things that we've done.
So do you feel like your average customer knows what data science is, or is there some education around that? And how do you explain that to people who maybe don't know exactly what you're talking about?
Great question. I think the majority of our clientele, especially ones that are hiring us to build their data science team, they don't know what it's called and they don't understand what it is, but they know that they need to do something. They've got data. They know it can help them. A lot of times they're using it in reports. They've got near-time reporting. They're using Spotfire or ClickView or Tableau or some sort of visualization software to understand their data better. But that's all past data. That's all data that's backwards looking. And at some point, somebody says, okay, that's great. I'm glad that happened last quarter, last week, yesterday. What's going to happen tomorrow, next week, next month, next year? That's predictive. And that's where predictive analytics comes in.
So you guys don't do the data warehouse part of it, like what you say, the backwards looking part. That's assumed that's kind of already there. And then you bring in the predictive analytics where you can start looking for it. Is that usually the case, or?
Most of the time that is the case. If someone comes to us, there's always a little bit of transition from the data warehouse, the BI piece. We can actually do the full suite of BI and data warehouse. In fact, we've been hired to build data warehouses before. A lot of times they have databases, but they are not set up to be data warehouses, or they're not set up to be used in predictive analytics. They're not set up to use they're not set up as the right schemas, or there's multiple databases, which tends to happen a lot in bigger companies, and we've got to fix that. We've got to have all the data in one spot in a data warehouse. And so a lot of times, even though we want to build predictive analytics as our first step's really wrangling data.
Okay. So you guys you don't have to necessarily go just after the mature customer who has all that stuff in place. You're looking at maybe they're at step 1 or 2. They have transactional application layers and things like that, and help them go from that to the data warehouse and then to the predictive analytics.
Yes. Ideally, they've already been doing the visualization piece. They've got a healthy BI type of ability, but that's not always the case. A lot of times people understand that they see the need for predictive long before they even build the reporting piece out. And so they're coming to us even pre-BI, which is fine. We help them get that piece up and running and then build the predictive analytics. In fact, it becomes a 1-2 punch where we're building the BI with the full realization that we're doing predictive analytics on it, and it actually becomes easier that way. You don't have to throw anything out or start over in any one place because you've always had predictive analytics as the main goal.
Cool. Can you talk about like some of the clients you do and like some of the things you predict? Because I think that's a part that's interesting to me is like what's real world examples of like how predictive analytics help a business actually make their decisions. Ultimately, like save money, save time, right? That's the end game.
Sure. It's funny being a sales and marketing guy. My favorite examples are always in the sales and marketing side of business. Everybody's always heard that comment. 50% of marketing is bad. We just don't know which 50%. The predictive analytics helps you figure out which 50%. So we've had a number of clients. We've had a credit union. We've had a gym. We've had a number of clients who've really used us for things like loyalty campaigns. Who's getting ready to leave your business? What are they getting ready to buy when they leave? So the ironic thing, especially in banking, is the majority of people leave a bank to go to a different bank to buy a product that the first bank actually had, but nobody ever told them.
Oh, okay.
So predicting things like when do people need a second product? When do they need to be called? When do they need a different product? Like I went to the bank, I was 20-something years old, I bought a checking account and a savings account that is specifically for a single person in their 20s and how they live. I'm now, unfortunately, in my mid to high 30s. I now have a child and a wife. My banking is different. And I save differently. I actually save for things, right? In my 20s, I never saved anything except for Friday night. Save for Friday night. So my banking needs are different. Well, nobody at the bank's ever called me.
Yeah.
Even though they have hundreds and hundreds of 30-year-olds that are married and have children and save the way that I'm saving now, they actually have really great insight into how I should be acting as a 30-year-old. No one's ever called me. Well, we can do that. We can start to predict this person is changing their saving ways or their spending habits. You should call them and change their entire portfolio. We've seen a number of companies look at cross sales. I mean, there's this big realization now that, you know what, we've spent all this money getting these customers. We never spend any money keeping these customers. Oh, and by the way, the easiest sale is the cross sale. We've never spent any money cross-selling these individuals other than sending them pamphlets of things that we sell. Why don't we actually have a focused salesperson calling on people just like they do for new sales, but instead calling customers that already have a relationship with us, that take our phone calls, already have a product with us. It's the easiest sale in the world, but nobody does it because it takes data, and it takes data science, and it takes smart data. And that's what we build, at least in that realm. We've had a number of companies that have used us for their customer service teams. So people call in to make a payment or to change a product, and you have a customer service person on the phone. They're almost never salespeople. They are, and I love them, but they're the lowest paid person usually in the company. Well, we provide the ability by predicting based on personality, demographics, psychographics, those types of things. We can predict what they're likely to buy. So I now have, or can give, these call center individuals flags that says this person is most likely to buy product 72, right? And so the little product 72 paragraph comes up on their screen. They can read it. It's just a paragraph. Talks about product 72. Mr. and Mrs. Smith, thanks for calling and taking your payment. Hey, I noticed you've been with us for 18 months. A lot of our customers about the 18-month mark are looking to switch or to buy this product 72, mysterious product 72. Would you be interested? This is what it does. And if they're interested, then they get transferred to a real salesperson who can answer all the questions, who can ask the right questions to get them to buy that product. So now you're giving sales competency to, or at least lead uncovery to a customer service agent when someone's on the phone. And we've done that as well.
So one thing I was thinking is with your consultants, the data scientist, it's not necessarily like a hard science, right? Like you can find patterns, but then is that part of the job of CAN is to actually find those patterns but then find meaning out of them? Or do you rely on the business to kind of find the meaning out of the patterns? Does that make sense? Because then you have to kind of you as a consulting firm are going to have to kind of get into each industry and understand like what are the patterns of people who bank and their age and their demographics and all that stuff. It's not just purely relationships, but it's almost understanding that business, understanding psychology of people. Does that fall on you guys, or does that fall on the client?
So there's a really interesting concept that a chess master, someone who actually is a chess wizard, they can beat a computer, the smartest computers that are out there, because they think differently than a computer. But if you give a novice Watson, they can beat the chess master every time. So a computer and a person are better than any expert. So what we're giving is that computer, right? That's the data science piece of it, the predictive model. We're giving that plus the ability for any salesperson, the ability to put in their little bit of knowledge about the business, and that combination is better than any one expert. So the what do you call it? The subject matter expert, the SME, is provided by that bank or construction company or ag tech business or finance or whatever industry that we're in. They're providing the subject matter expert. Now, to build our models, we're using the knowledge from that subject matter expert. And when we're finished, that subject matter expert is 125%, 150% more able to get to the solution. The real value is actually the subject matter expert helped us build that, right? We're giving subject matter expert decision making to a entry level individual. And that's what the great thing about data science is. So you're taking something that a 30-year veteran took 30 years to figure out their subject matter expertise, and you're building that into the model and then giving it to someone who's only been in the business for 2 years. They aren't 100% as accurate as that subject matter expert, but they're close. And every business I've been with is like, that's amazing. I'll take, if you can get a 2-year person to a 10-year person, not all the way to the 30-year veteran, but if you can get a entry-level person to that 10-year person, I'll take that every day of the week. And then we do, and that's exactly what it does. So I didn't exactly answer your question because it just depends, right? So I have a lot of expertise in construction and ag tech. I have other data scientists that are experts in finance and banking and risk management. And so we do have some subject matter expertise that we bring to the table, but we really do rely on the subject matter expertise of the company to help us build those models.
So if you can predict the future, every guys are well, then just figure out what the stock market's doing and go after that, or
Of course.
is that just too complicated to figure out, or?
So the interesting thing is what some of our guys have actually done. You can't predict individual stocks and which ones are going to go up and down, but you can predict things like, is the stock market as a general rule going to go up for the day or down for the day? And we've gotten pretty accurate at things like that. Right now we're being hired to predict the price of cattle. We're building a risk management tool, a steer profitability tool for a feedlot that they're going to then resell to 1,000 other feedlots, and it's going to help them buy hedges against the market going up or down. So we're predicting if the market's going to go up or down and by what magnitude, and then they'll be able to hedge their risk based on, well, I bought cattle at $117. I buy a call or sell a put based on which way it's going to go from there. So yeah, we do some of that. We dabble in that.
So you ever put your money on the prediction there?
Of course. It's funny. One of my head data scientists predicted a Trump landslide in the
election.
Not the election. What's the electoral college?
Oh.
So he predicted electoral college landslide and went to Vegas and put $1,000 on the electoral college.
Oh, really? I didn't know you could bet on that kind of stuff.
You can bet on everything in Vegas.
Okay.
Yeah, you sure can. You can bet on everything. And he won some money, which means our Christmas presents to the bosses were really nice this year. Thank you for my scotch. And yeah, so we do. We see that. We tend not to. The interesting thing about predictive analytics is the guys who do predictive analytics every day. So the actual data scientists, the mathematicians, the economists, they know that their models are 70, 75% accurate.
Yeah.
And so when you're knee deep in the model and you know that that you can only ever explain 60, 70% of the variances in the models, they're very skeptical about betting on things like that. Now, to all of us out here in the real world, we're like, yeah, 65%, that sounds great. But data scientists are of the mindset that, well, that means there's 35% of variance. I can't lay that kind of money on a 35% chance. Yeah, but Vegas is.
Over the long run, though, if you have a 75%, right?
It's the long run play. So,
Yeah.
we actually have a couple of our data scientists have models that predict who's going to win football games. One of them it's pro and the other one's college. And we've kicked around selling subscriptions to those models because it's better than Vegas by
That might just be a good
4 or 5%.
good marketing deal for you guys, like putting that stuff out. Like, hey, of course it kind of depends if it wins, but you could just like the analysis, maybe not saying like, oh, the Huskers are going to win, but
Never bet on your home team.
70%. There's a bias there.
There's always, you hear too much on the radio. You have a passion, right? You have this big N on your chest, and like they're going to win. Well, all the things say that they're not. Yeah, but I know emotionally they're going to win. Never bet on the home team.
Okay, that's good advice. Cool. Well, one of the things we want to maybe take a break, and we'll come back in our second segment. I want to talk about. It sounds like this would be a hard position to hire for. And some of the challenges of finding talent in Omaha, and also a little bit about maybe how the Data Science Academy plays into that. And so if we stay tuned, we'll come right back and we'll jump in. Okay, guys, welcome back to segment 2 here with Nate Watson from Contemporary Analysis. We were talking a little bit about what data science is and what can the services they provide. One of the first questions I had was, that seems like it'd be pretty hard to find people who can actually do that, right? Especially in Omaha, Nebraska. So one, I wanted to talk about some of the challenges, finding talent, and then how are you guys able to compete with maybe some larger companies on the coast, things like that. So start with that, and then talk about maybe segue into how the Data Science Academy is trying to solve some of those problems.
Yeah, it's interesting. We do struggle with, just like every company that has a resource that is scarce or scarcer than scarce, struggles with, and that is where do you find talent? What's interesting about the city of Omaha is we probably have total, completely all in, everybody who's even sort of a data scientist, 50, maybe. That's it. So to build a company that actually has data science by the hour, that has data scientists for rent, and have any kind of scalability is very, very difficult.
Well, especially, you allow the companies to hire your consultants potentially, or?
Yeah, if long as it's above board and they come to us and pay us, copious amounts of money to do so, then yes.
Okay.
We will allow it. So we had to create a culture that really didn't exist anywhere else, and that is we had to create a culture that we solve multiple problems in multiple fields, and they're the hardest problems that we can lay our hands on. So the people who are excited about the problem solving, they're very attracted to come work for us. We created a culture that you can work full-time somewhere and still do data science for me part-time. So nights and weekends, we have quite a few data scientists who work nights and weekends for us and still are full-time at Union Pacific or other companies that will remain nameless because they have to. We have... Luckily, the Creighton and the UNOs of the world have started to produce data scientists. So what's really interesting in Omaha is that we grade all of our data scientists from 1 to 5, 1 being entry level, 5 being PhD type level. We have a whole lot of 4s and 5s in this city, and we have starting to get a whole lot of 1s because of the degree programs. We don't have any 2s and 3s. And so there's a real lack of affordable talent. While the PhDs are amazing and they do amazing work, and I have a couple of them that work for me on the side, they are really expensive. Also, ConAgra leaving freed up about 5 to 10 data scientists, which is great. So I benefited greatly from my quote-unquote ex-cons, which is what they call themselves, and I think that's hilarious. But then we really saw that we had to do something different, right? We can't wait for the ones to become twos to become threes. I mean, that we are and we will, but that's a 5-10 year process. What do we do now for data science? What do we do now for companies that want and need data science talent? So we created this thing called Data Science Academy. Data Science Academy came out of this idea. It's actually using interfaces type of model. Enterprise Web School, Shauna Dorsey, great academy here in town, really designed for adults to go back and learn programming. So we took that same idea. There's a lot of individuals who have MBAs or they already have a degree of some sort. They're working in IT, they're working in accounting, they're working in some fashion. They're really using one of what we consider the 4 pillars of data science, which is programming, mathematics and statistics, database, data visualization. So they're in one of those fields. They're already working one of those fields. They want to be a data scientist. They're really close to being a data scientist. But going to get a degree is ridiculous. They don't need they don't need another $40,000 degree. They already have one. They're still paying on it. So really all they need is a skill set. So we decided to build this thing called the Data Science Academy that taught them over the course of 18 weeks the skill sets needed to be an entry-level data scientist. So the cool thing is that college is kicking out these DS1s. They have essentially the same skill set as ours do, but they have no business acumen, right? They have no idea of how to apply that theory back to business. Our guys, however, and gals, our generic guys, are coming out of the Data Science Academy. They've been taught by data scientists real data science. So they're not being taught theory, they're actually being taught something that they probably did 3 or 4 hours ago during the day because it's the night. So our data scientists working for the Wests and the Sojourns and the TD Ameritrades and the Union Pacifics of the world, and then they go and teach these classes of what they actually just did. So it's not collegiate in the sense that it takes 4 years to make it into the textbook. The stuff is 45 minutes old sometimes. They're learning real-world data science, but they already have business acumen. So when they come out, they're not a DS1. They're not really a DS2 either, but they get to DS2 really fast. So an internship or an apprenticeship, 6 months later, they're a DS2, and we're seeing that companies are eating this up, right? There's a big demand for these individuals. They're getting a $10,000, $20,000 pay bump because now they're actually a data scientist. And we're filling a gap in the community that needed to be filled. Yeah.
So 16 weeks, is that like 18 weeks, is that like nights and weekends, or is that intensive like during work hours?
It's all nights and weekends because these people have full-time jobs. Yeah.
Okay.
Specifically built for individuals that have a 8 to 5 job, 9 to 5 job, 6 to 6 job, whatever their job is.
And are people from your company teaching these classes or involved in some way, or who's actually giving the classes? So
it is individuals from my company, or it's individuals that I have used to do data science. So I have a really interesting mixture of contractors, part-time and full-time employees. And so it's individuals that are part-time and full-time employees for me, but it's also contractors, which means they aren't technically working for me, or they are, but they don't have my logo. But it's all individuals that I have experience with that I'm paying to do a project for me. So I have experienced their technical capability firsthand. So
when you go through this program, is it a variety of people that you'll be working with through those 18 weeks that have maybe different expertise within that profession? Or
yeah, so we broke it up into 4 modules. Each of the 4 pillars has their own module, and each of the 4 pillars has their own teacher.
Okay.
That is specializes in that. So Matt Hoover, employee of mine, he's an ex-con.
You gotta be careful saying that.
I know, but it's still my favorite term. He's an ex-con agrin. He is a Tableau whiz kid, and he teaches Tableau. And then what we do to additionally is we bring in data scientists from the community as well. And they talk about what they do specific. Kelly Burdine out of Huddle came to one of our classes. She talked specifically about what she does at Huddle. How does she use data science? What were some of the political hoops that she had to jump through to get data science implemented at Huddle? Those are the types of it. So we bring in these data science giants from the 20, 25 companies that are using data science in Omaha, and we bring them in and have them do a 30-minute. They take 30 minutes of the class to talk about what they're doing. The other great thing that provides really is a network. So one of the great things about having a data science academy is we introduce you to all of the data science giants in the area, and that allows you then to have this network of people. So even if you go and work and you're the first data scientist at a company, you now have the ability to call upon the head of data science at Huddle, the head of data science at HDR, the head of data science at Tenaska, and ask them questions that really gives you insight over hiring a collegiate student who doesn't really have this network. You can call a professor, but that's not the same thing as calling a data scientist who's been practicing data science in a business for 10 years.
Okay, cool. So one last thing, and then we'll wrap up the show here and give you a chance to kind of plug whatever websites you want. We actually met, I think, we went through Derek, student sales, but you're down at the Startup Collaborative still?
I am.
Okay. How's your experience going down there? Are you guys?
The Startup Collaborative is great. So we moved from 12th and Harney. We went to build a product, and so we went way out west. We went to 114th and Davenport, and we finished up that contract there. We were looking for a place that was back downtown. We were looking for a community that had a lot of the thinkers in Omaha, who were the people who were trying to start things, who had the best ideas in Omaha. And that's who we wanted to be around. And the Startup Collaborative is that. It's a community of individuals who are trying to start companies. They're hopefully the best and brightest, or that's what they're trying to attract, is the best and brightest in town. I would tell you that some of the people that are down there really are the best and brightest in town. It's a smattering of companies from all across genre. So it gives you an insight as to where banking is, where websites were at, where are all of these industries at in their ability to process information, use data, get into predictive analytics. Cool thing is that every one of those people comes out of those industries, has a million connections, and I can take advantage of that hopefully through networking and through being friends with them.
Cool. All right. Well, one last thing, if you want to share with everybody what websites,
Sure.
Twitter, whatever how people can get in touch with you.
So contemporary analysis is Can Work Smart, CanWorksmart. We have a really nice blog that our alumni post on all the time. We write articles, interesting things that are in the community. Omaha Data Science Academy, which is really long but easy to spell, omahaDataScienceAcademy.com, is a fairly new website. It needs a lot of help, but we'll get there. It is where the data science information is going to be. Also, interfacewebschool.com is the actual application site for the Data Science Academy. Since they're doing all the administration, that's where you go to sign up. Then you can call me, Nate at canworksmart.com. I'd love to get emails from people who have questions, comments, things you want me to talk about, ask about, or build.
Cool. All right. Well, thanks for being on the show, Nate,
My pleasure.
Sharing about your company, Can. Sounds really exciting, and hope to hear more from you. Thanks.
Thank you very much.
Thanks, guys.